We do some more work with double angle identities. How about that? Well, let's see what we have here. It says find the exact value of the expression if the cosine of theta equals -1/3 and it lies in the quadrant 2 between 90 and 180 degrees. Well, we do have a double angle identity. Let's take a look at that. So the cosine of 2 theta, we got to find the cosine of 2 theta, excuse me. That's what we're trying to find, cosine of 2 theta. And our double angle identity is that the cosine of 2 theta is equal to 2 times the cosine squared of theta minus 1. That's one of the 3 double angle identities we could use to find the double angle of cosine 2 times theta. And since what we know is the cosine, I'm just sticking with this particular one. And so let's go here to the next step. We're going to insert some information. So we can say that the cosine of 2 times theta is equal to 2 times -1/3 squared minus 1. Well, -1/3 squared is equal to 1/9. So now we got 2 times 1/9 minus 1. And then when we multiply the 2 times the 1/9, we're going to get 2/9 minus 9/9. Re-expressing that -1 is -9/9. And shazam, 2/9 minus 9/9 is equal to -7/9. And the cosine of 2 times theta, when the cosine is equal to -1/3, is (sine/9). I have a feeling we should do one more. Shall we? Of course. All right, let's see. This time find the exact value of the expression. Same parameters. The cosine of theta is equal to -1/3. We're in the second quadrant. We're between 90 and, initially in the second quadrant, between 90 and 180 degrees, and we're asked to find the tangent of 2 times theta. And we have a double angle identity for the tangent of 2 times theta. And that double angle identity is that the tangent of 2 theta is equal to 2 times tangent of theta divided by 1 minus the tangent squared of theta. Now I got to do a little work here before we begin. And that is, we know the cosine, but we don't yet know the sine. Now, of course, the tangent is equal to, I'm going to do a couple of things here. One, it is the opposite over the hypotenuse. No, excuse me. That's the sine. I got to find the sine of theta. So the sine is the opposite over the hypotenuse, and the tangent is the sine over the cosine. Well, I'm going to have to find the sine to proceed. So let's see. Let's just schedule something here. We're over here in the second quadrant. Let's get us a right angle. We know that our hypotenuse, because the cosine, again, SOHCAHTOA, is the adjacent over the hypotenuse. So my hypotenuse is obviously 3. Here's theta here. And so this is -1. And I want to find this opposite side. So let's say we're going to call this B again. We've done this, I think, before already. So we got -1 squared plus B squared equals 3 squared. And we're trying to find the opposite side. So that's 1 plus B squared equals 9. And B squared is equal to 8 And so b is equal to the square root of 2 over 2. So that's the, 2 times the square root of 2. Getting ahead of myself. 2 times the square root of 2. So that means that the sine is going to be equal to 2 square root of 2 over the hypotenuse of 3. Now, what about the tangent? We'll move over here. So the tangent is the sine over the cosine, and we now have determined that the sine is 2 times the square root of 2 over 3, and the cosine is negative 1 over 3. So to find the tangent, we got 2 square root of 2 over 3 times, we're going to divide by that negative 1/3, which is the same as multiplying by negative 3 over 1. And my 3's cancel out. I'm left with negative 1. So the tangent of theta in this example is negative 2 square root of 2. I better plug in some power here, or we're not going to finish this little video. Excuse me, just a momento. All right, there we go. We're powered up. All right, so now we're ready to substitute. We're saying that our tangent is negative 2 square root of 2. Given the cosine was equal to negative 1/3, we found the sine, then we found the tangent, and we're ready now to find the tangent of 2 theta. So we got 2 times the tangent of theta. Well, that's 2 times negative 2 square root of 2 over 1 minus the tangent squared. Well, that's negative 2 square root of 2 squared. Let's see, 2 times negative 2 square root of 2 in the numerator gives us negative 4 square root of 2. And 2 square root of 2 squared, well, let's see, 2 squared is 4, and the square root of 2 is squared is 2, and so we got 4 times 2, that's going to equal 8. So now we're here at negative 4 square root of 2 over 1 minus 8. And so therefore, think about it here, I'm going to have a negative here, because this is going to be negative 7. So we got a negative in the numerator and a negative in the denominator, and that's going to make our overall result a positive. So the tangent of 2 theta is equal to 4 square root of 2 over 7. That probably deserves a Shazam.